objective solving optimization. Optimization means when something is maximizing or minimizing, like you want to maximize the box or minimize the box or maximize the area or minimize the volume, something like that. So that's optimization. These are few steps that we have to follow it. So first step, determine the quantity that is to be maximized or minimized. So I'm gonna use one step by step while solving the problem. So I have to figure it out which quantity is maximizing or minimizing. If you guys read it, a manufacturer wants to design open box having a square base and surface area of 108 square inches. What dimensions will produce a box with a maximum volume? What is the maximum volume? So what am I maximizing? The volume of the box, open box. So I identified that. Now draw a picture and write primary and secondary equations. Okay, so I have to draw you have to draw a picture. It doesn't have to be like perfect as long as you understand. Uh, it's not pretty, but we can figure it out what they're asking. They said a manufacturer wants to design open box, so the top portion is completely open, having a square base. The base, this is a base, and that's square. Square means all the sides are the same. So this is x, that's x, this is also x, and that one is also x. In a surface area of 108 square inches, what dimension? Oh, this is actually the y, the height. What dimensions will produce a box with the maximum volume? So I draw a picture and I also draw a picture and write primary and secondary equations. What is primary equations? Primary equation means represent the quantity that is to be maximized or minimized. So my primary equations is the volume equation. So my primary equation is volume. So what is the volume of this box? Remember, volume has a general formula for any kind of shape. You're going to use this general formula. It's big BH. That's all. Remember it. What is big B? That's area of the base. Now our base was square. So what is the area of the square? It's x squared. What is the height? It's a y. So that's my primary. That's my primary equation. Okay, that's my primary equation. Now, what is my secondary equation? Secondary equation is talking about surface area. So I have to find the surface area of this box. So the surface area equal, and surface area formula, how do we find surface area of different shapes? Area of each and every side. Since the top portion is open, then I have like that one, two, three, four sides, and one is the base. So what is the area of the base? That side, that's x squared. We already know that. Plus, what is the area of all the rectangles? Because why would I say rectangles? Because this is y and that is x, which means they are different. Like the this line and the height, they are different. So it has to be rectangle. So how many sides I have? I have, let me do this. I have this side and I have that side. So two sides. Then I have three, and this is four. So technically I have four sides. So I'm going to do four. And what is the rectangle area? X and Y, length times width. So this is my surface area formula. Surface area formula means area of each side. Volume is big BH. What is big B? Area of the base. So I'm going to just write here, big B is area of the base. Or whatever shape base you have, you're going to find the area of that. Okay. So now what do we do? Next step is this side. Primary equation represents a quantity. We've already said that. Do not change the primary equation. Primary equation was that one. I'm not changing it at all. I'm not touching it. Isolate one of the variable in the secondary equation. So this is my secondary equation, and I'm going to isolate y because y looks easier because I have two x's and that one is square, so it would be hard. Let's do y. So surface area, we already know it's 108. So x squared plus 4xy. Isolate the y, get rid of the x square, get rid of 4, get rid of x. So let's get rid of x squared first. So subtract x squared, opposite operation. I'm getting 108 minus x squared equal 4xy. Get rid of 4x. I'm dividing 4x both sides. So I'm left with y equal 108 divided by 4x minus x squared over 4x. Why I'm splitting the fraction? Because I want to simplify it. Okay, if I can, but I just split it and see if we can simplify. 108 divided by 4 is going to give me 27. X is going to stay down there because 4 and 108 gone. So the X is staying minus, since I have the same basis, X squared and X same basis, and I'm dividing. So the exponential property means I'm subtracting exponents. So I'm going to have that 4 in the bottom. Uh, but I'm gonna have 2 subtract 1, which is x to the power 1. So this is what I got, simplified form. Now, replace that variable, like this y variable, in the primary equation, which is right here, and take a derivative. So my primary equation is v equal x squared y, and I'm gonna replace this y with the equation that we have, 27 over x minus x over 4. I got that. Now simplify further because it's going to be quotient rules and it's going to be product rule when we take a derivative. So let's see if we can distribute. So this x cancel out with one of the x. So I am getting 27x minus this is going to be x squared times x is going to give me x cubed over 4. So this is what I'm getting. I can rewrite this one more time to get rid of this quotient rule. So that's minus 1/4 x cubed. This is what I got for the simplified version. Now I am going to take a derivative on that. So I'm going to take v prime x equal 27x derivative is 27 minus 3 jump to the front. So I got 3/4 x. 3 subtract 1 is going to give me 2. So this is what I got. Now you're going to make this equal 0. And then we will get the x by itself. Once we get the x by itself, then they are asking for the dimension. What is the maximum volume and what dimensions will produce. So the x is one dimension, then we have to find the y dimension. That's my one part of the question. Then we're going to figure it out the volume when we get the x and y both. So get the x by itself. So I am getting 27 minus 3/4. I want to write it one more time, equals 0. Subtract 27 both sides. So I'm getting negative 3/4 x squared equal negative 27. Now, make sure that 3/4 is multiplying. So if I multiply both sides with negative 4/3 times negative 4/3, I did the reciprocal of it. You can also divide 3, negative 3/4 both sides. You have to do the reciprocal anyway. So they cancel out, This is negative, negative turn positive. And this one negative, negative, positive 2. I got x squared equal 3 and 27 is 9, negative 36. So x is going to be positive negative 36. I'm sorry, not 36, 6, because we are square rooting those, right? To get rid of the x squared. So that's 6. 36 is 6. We are looking for positive 6 because we are maximizing, so we are not including this negative. It's a positive 6. So 6 is my x value. How do I get the y value? You can plug in this x in the surface area equation and you will get the y value. So if I plug in this x, um, so if I plug in this 6 in this surface area equation, it's going to give me 108. 6 times 6 is 36 plus 4 times 6 times y. So that's 36y. No, not 36, 24. So I got 24y plus 36 and then 108. So 108, subtract 36 from 108. So I got 108 subtract 36, which will give me 72 equal 24y. Now divide 24 both sides. So 72 divided by 24, the answer is 3. So I got y equal 3. So these are the dimensions. They say what dimension will produce a box with a maximum value. So since we know x is 6 and the y value is 3, so we got everything. And since x value means 6 by 6, that's the dimension. So I'm gonna say the dimensions are dimensions. Okay, how do we write dimensions? We're gonna, since x is the length and the width, so I'm gonna go 6 inches by 6 inches and then by 3 inches. That's the height, like x in the height. The first one, the second, and the third. Now they are also asking what is the maximum volume. So we have to plug in, use a volume formula, which is x squared y. And I will plug in that 6 here for this. That's 36 and 3. So it's 108. So the volume is 108. That's the maximum volume, inches cube, because volume is always cube. So this is too much stuff, a lot of stuff, but you will get used to it. So this is how we use optimization.
Example number 2, a box is to be built from a rectangular piece of cardboard. This is my rectangular piece of cardboard, and that is 25 centimeter wide and 40 centimeter long, by cutting out squares, these black one squares, each corner, and then bending up the sides. Find the size of the corners, which will produce a container that will hold the most amount of soup. So since I'm talking about volume, because most amount of soup in this box, that's volume. So if this is a volume I'm looking for how much maximum soup can fit in this box. So maximizing volume. So according to my steps for the optimization, it says number 1, determine the quantity that is to be maximized or minimized, which is volume in this case. Draw a picture, we already did. Write primary and secondary equations, and then the primary equation is the one that represent maximize or minimized quantity. So in this case, my primary and secondary equations, I know volume is going to be my primary equation because this is what we are maximizing. So we are doing volume. The secondary equation, I don't have it in this question, so we're going to ignore that part. Now we are going, if we had a secondary equation, we will do step 4. Since I don't have it, then I'll just have to have a take a derivative of the primary equation. So after we figure it out what the equation is. So I already told you guys in the first example, the general formula for the volume is big BH. What is big B? Big B is area of the base. Just remember that, area of the base. That's what big B is. Now, so let's find out what is the base. The base looks like a rectangle to me. The width is 25 and the length is 40. But when we cut these squares, so this portion is gone, this portion is gone, that portion is gone. So which means I'm only talking about a length of this. So I'm going to have a 40 subtract 2x, because I have 2x, I cut them. You have 25 and subtract 2x again here. So that's my length, that's my width. So what is the area of the base? Length times width. So volume is equal length times width, which is 25 minus 2x, or width times length, either way, 40 minus 2x. What is the height? H. When we bend this portion and cut these squares, the bending, just imagine the bending, so that's the height. So x is the height. Now let's fix this around before we take a derivative of it. So we're gonna FOIL this first. 25 times 40 is 1000. 25 times 2 is negative 50x. 2 times 40 is negative 80x. And negative negative is positive 4x squared. And I also have that x outside. Now let's combine the like terms. So I got 1000 minus 130x plus 4x squared. And I still have that x right there. Now we're gonna go up here to see distribute that x. So volume is equal 4x cube. I'm putting it in order. So x squared and x1 is x cube. Then I have minus 130x squared and plus 1000x. Now we can take a derivative of that. We prime x. That would be 12x squared minus 12x squared minus 260x plus 100. So plus 1000, I'm sorry. So this is what I got for derivative. Now we're going to make this equal 0 since they are asking for the size of the corner, square corner, which will produce a container. So I need the x value actually. What is my x value? That's the side of the square corner that we cut out. So I'm gonna make the x by itself. If it was free calculator questions, then I'll just graph this and I will make another tab equals 0 and point of intersection. But you guys can understand this 1000 is a big, huge number. 260 is also big. So what we can do, we can find a number to make it smaller. Okay, it's not gonna change anything. To make it smaller, divide all these three coefficients, 1000, 260, and 12 by one number. So it has to be same number. So we can divide all four of them by 4. So 12 divided by 4 is going to give me 3x squared minus, you divide this by 4, it's going to be 65x. You divide this by 4, so it's going to give me 250. So it's got like kind of smaller. It's get to the 250 at least. So you guys can graph this if it's a calculator based question. If it's not, then we have to factor it out. The factors for 3x is 3x and x. For the factor of 250, 250 is going to be 50 and 5. I don't know if the 50 and 5 is going to work. We can find another one if it doesn't work. So we have to, and since the minus is in the beginning, which means both of the factors are minus. So 3x goes here, x goes here. I have a 50 and I have a 5. If you FOIL this in your head and you get back the same thing again, then which means your factors, the factors you picked are correct. Otherwise we change the factor and we pick something else. So 3x minus 50 equals 0 and x minus 5 equals 0. X equal 50 over 3 and another one is x equal 5. Now if you guys remember, the first one was positive and negative 6, so we can't have a negative because they were asking how to maximize the volume, so we have to get the positive 6. In this case, since we have both of them and both of them are positive, then I'm going to make a sign chart and we will figure it out which one goes. So this is 5 and this is 50 over 3. We pick something here and plug it in the V prime. I'll probably pick 0. It will give me positive. When I pick here V prime 6, you plug in 6, you're going to get negative. Plug in here, this 50 divided by 3, change it into decimal is 16.6. So I'm going to pick 17 here, V prime 17. And this is going to give me positive. So positive to negative, that's where it's maximum. So I'm going to say we're going to pick x equal 5 instead of 50 over 3.
Now we are giving them justification, which would be volume is maximized when the square is 5 centimeter by 5 centimeter, because we prime x changes sign from positive to negative. Number 3, a rectangular page is to contain 24 square inches of print. A page is to contain 24 square inches of print. So these squiggly lines are my print. In the area that contains just the print is 24 square inches. So what does that mean? It means area of the page, area of the print is equal 24 square inches of. The margins at the top and bottom of the page are to be 1.5 inches. So the blue top and bottom margins are 1.5, and the margins on the left and right are to be 1 inch. What should be the dimension of the page so that the least amount of paper is used? And they're asking for the dimension of the page. So this whole thing is my page. I I can say from here to here, like where the print is, that's X, because I only know this margin and that margin. So 1.5 and 1.5 will give me plus 3, because I have to count all of this, that dimension of the page. So that's the length. The width is going to be Y plus 2, because we have this portion from here to here is where the writing is, the print is, but I also need this margin, so which is 1 inch both sides, which makes it plus 2. So that's my width, that's my length. Okay, where of the print is equal 24. This area of the print is 24, and area of the page is going to be length times width, that we don't know. So they're asking least amount of paper is used. The paper area they are talking about, least, like minimum area of the paper used, which means this is my primary equation, the one we don't touch, we don't do anything with it. And this is my secondary equation. So let's make our equations, like officially make them, use their variables. So area of the print is equal 24, and this is going the secondary equation, and area of the print means x and y, like length times width, because we know this is x and this whole thing is y. So that's the area of the print. So I got this secondary equation. I'm just going to write here secondary equation. Now we need area of the page. Area of the page is equal A equal length times width. So my length for the page is x plus 3, and the width is x plus 2. So this is my primary equation that I said we are not going to touch. We only gonna replace and we take a derivative of it. X plus 3, no, this is y plus 3. Sorry, x plus 3, and this one is y plus 2. So this is actually y plus 2. So this is my primary equation. Now let's figure it out. How can we make the secondary equation one variable by itself? So my secondary equation is 24 equal xy. I'm going to divide x both sides so I can make the y by itself, and it's 24 over x. Now replace the y in the primary equation with this 24 over x. So my primary equation is a of x equal x plus 3 parentheses, and for the y I'm replacing 24x plus 2 and close. So this is what I got. Now we have to take a derivative of the primary equation, but we have to simplify this whole thing. So x times, and I'm foiling, x times 24 over x cancel out, I'm left with 24. So I got a of x equal 24. Now I have to multiply plus 2x, the x and the 2. Now I'm doing 3 and 24x. So 24 times 3, okay, I'm going to go plus 24, 3 times 4 is 12, and 72, and I still have that x in the denominator. Now I'm going to do 3 times 2, which is 6. So this is what I got so far. I have to do something about this so we don't have to use a quotient rule. Now I'm taking a derivative of this, okay? So let's try the derivative of a prime x equal 24 derivative is 0, 2x derivative is 2. How do I do this? I'm going to rewrite this like, let me rewrite this over here, okay? It's going to be 72 x to the power negative 1. So let's take a derivative of this, which is negative 72x negative 2. So this is what I got for the derivative. We're going to make it equal 0 because we need the x value to see which one, x and y both, so we can see how much the least amount of the paper, like the area of the paper we use. So I'm going to do negative 72x negative 2 equal negative 2 over here. I can make negative 72 over x squared equal negative 2. Now make this one and cross multiply. So I'm getting negative 72 equal negative 2x squared. Divide negative 2 both sides. And I'm going to get x squared equal negative negative cancel out. And I'm getting 36. Now, okay, negative 72 over negative 2 cancel out. And I have a square root 36, which means x is equal 36. Sorry, x is equal 6. You can say positive negative 6. I mean, we will see which one works for us. So I'm going to make a sign chart. This is negative 6 and that's positive 6. And my derivative is actually this portion. This is my derivative, which I'm going to use a calculator and figure it out what the numbers are. So I have a prime negative 7, a prime 0, and a prime 7. So let's plug in negative 7 first, which I already did, and I'm getting positive answer. When I plug in 0 in here, so I got 2 minus 72, and I have 0, 0 to the power negative 2. This is giving me error because it's going to go undefined. If we can plug in here 1, let's see how the 1 goes. Because 0 is giving me undefined, it's not going to work. So I'm going to go to minus 72, and this is going to be 1. So I'm going to go 1, and to the power negative 2 is going to give me negative answer. So this is negative. And when I plug in 7, this is giving me positive. Since they are asking least amount of paper used, which means they are asking for minimum. So where is my minimum? Negative to positive, which is positive 6. This is maximum, negative 6. This is minimum. So it means area of the paper is minimum when x is equal 6. When x is equal 6, because a prime x changes signs from negative to positive. So these are my 6 inches, my x is equal 6. Now I also need a y value. So if I plug in x is equal 6, and for the y, I can plug in u. So how do I get the y value? We can get the y value when I can use this equation right here. I can use this one, the y equal 24 over x. So when I divide 24 by 6, I got 4. So y is equal 4. So that's my width, and this is my length. So I can say, what are the sides? X plus 3, 6, 7, 8, 9. So it's 9. is the length, and the width is 4 plus 2, 4, 5, 6. So 6 inches by 9 inches. So these are the size, like length and width for that rectangle, for this rectangle page. That we can use least amount of paper. Example number 4. A rectangle is bounded by the x and y axis and the graph of y equal 3 minus half x. What length and width should the rectangle have so that its area is maximized? Area maximized means area of a rectangle should be maximized. And so the area of the rectangle is my primary equation, which we don't touch. So I'm going to say this is y and this is x. So for the rectangle, so area of the rectangle is x times y, length times width. And we have another graph equation, which is y equal 3 minus half x. All I have to do is, since this is my primary equation, and we cannot touch this, we have to replace one of the variables with the secondary equation. That's my secondary equation. So y is already by itself in secondary equation. All I have to do is plug it in here. So a equal x 3 minus half x. Now let's distribute that, then we can take a derivative of primary equation. So I got 3x minus half x squared. I'm going to take a derivative of that, which is going to be a prime x equal 3x derivative is 3 minus 2 jump to the front. So it's 2 over 2 and x1, so they cancel out. So I'm left with 3 minus x equal a prime x. We make this equal 0, it's going to give me negative x and minus 3. At the end, I got x equal 3. Now, since they're asking maximum, so I'm looking for maximum where we go positive to negative. So I have to draw a tangent, I have to draw a sign chart 3, pick something here, a prime 0. When I plug in 0 in the derivative, when I plug in 0 in the derivative, actually I'm getting positive. I'm plugging it in here. I'm plugging in everything in here. Now plug in 4. When I plug in 4, 3 subtract 4 is negative. So 3 is the x where the one of the area, this is x. So I have to look for the y now. So I'm gonna first, let's explain this. Since a prime x changes from positive to negative at x equal 3, then the area of the rectangle, area of the rectangle is maximum. So area of the rectangle is maximum. Now, I need length and width. So I already know x is my length, which we got x is equal 3. So what is my width? What is my y value? I have to plug in this x in one of the equation to get the y. If I plug in x here, which is 3, 3 minus 3.5 is going to be, when I use a calculator, 3 subtract 3 divided by 2, it's going to give me 1.5. So my y is equal 1.5. So that means 3 by 1.5. And this is my answer for this. Example number 5. Determine the point on the line y equal 2x plus 3. So that's y equal 2x plus 3. So that the distance between the line and the point 1, 2, the distance between the line and you can pick any point on the line. So if I pick this point on the line, so they said that the distance between the line and the point 1, 2, this distance is a minimum. Minimum which means I'm going negative to positive, and I need, this is my, determine the point on the line so that the distance, so I need a distance formula, and that's my, uh, so distance is minimizing, which means that's my primary equation, and this is my secondary equation. So let's figure it out, the distance first, the primary one. So I got distance d of x equal, and we already know the distance formula, which was x minus 1 whole squared plus y plus 2 whole squared, which I'm talking about this. I mean y not plus, it's minus, and everything within the square root. So this is what my distance formula. And my another one is y equal uh, 2x plus 3. That's the one, the secondary one. That's the primary one. So we know that we don't touch the primary equation, but we do change the secondary, which is already y is by itself for the secondary one. So I have to just replace this y with that one. So this is my distance. I got x minus 1 whole squared plus, for the y, I'm going to plug in 2x plus 3, and I have minus 2 whole square and everything within the square root. Okay, so let's do the foiling and cancellation. So let's do this foiling. D of x equal everything within the square root. And I'm going to use a shortcut x squared, and minus stays here, and then I have negative 1 squared means positive 1, and then 2 times 1 is 2x. And this one is 2x plus 1 technically. 2x, I got plus, and I got 2x plus 1 whole squared. I have to FOIL this now. So I'm getting x squared minus 2x plus 1 plus, let's FOIL that, 4x squared plus 4x and plus 1. I can erase the parentheses because everything is plus, so even if I distribute something, it's going to stay the same. So this is what I got so far, equal. So x squared and 4x squared are like terms, so I'm going to make this 5x squared. 2x and 4x subtract, so that's plus 2x and plus 2. So this is what I have for the d of x. Now I have to take a derivative of this, and if you guys remember, for every time for the square root, we have to make it, rewrite it and make it half. Like square root is half. D of x equal, I'm going to do that, 5x squared plus 2x plus 2, and everything is half. Now I'm going to take a derivative of that. So let's try the derivative. I got d prime x equal, this is a chain rule, half jump to the front, keep everything inside as it is, don't touch anything, and half subtract 1 is negative half. So this is what I got times inside derivative, which is 10x plus 2. Yeah, that's my whole derivative for that. Now we know negative half is not acceptable, so I'm going to move that to the bottom. So I get d prime x equal, 2 is already in the bottom, 2x, 5x squared plus 2x plus 2, and everything within the square root there. And I'm left with 10x plus 2. So I got that. Now what else I can do here? D prime x, make it simpler. So I can simplify 2 times 5, and I can simplify 2 times 1. So I'm getting 5x plus 1, and then I have a square root 5x squared plus 2x plus 2. I'm going to make this equal 0, and we make this 1 and cross multiply. So this whole thing becomes 0 when I multiply. And 5x plus 1 times 1 is 5x plus 1 equals 0. Subtract 1 both sides. I'm getting 5x equal negative 1. And then you divide 5 both sides. So my x is equal negative 1/5. Now we have to make a sign chart to see if we are getting the minimum distance. So I make a sign chart. This is negative half. When I plug in, that was d prime. Let's plug in negative 6 here. When I plug in negative 6, I'm getting negatives. When I d prime 0, when I get this, I am getting, let's see, what is the derivative? This is the derivative. So when I plug in 0, so that's 0, that's 0 square root 2, and that 1. So it's positive. So this is giving me positive, which means negative 1/5 is the distance, minimum distance is at x equal negative 1/5. So now the question is also, are they asking the distance between the line and the point is going to determine the point on the line, So we have to actually look for this point. I drew it up here, but I don't know. We're looking for the point x and y. So what is that x and y there? Oh, I already got x is negative half. We got that idea. And now I'm going to get the y value. How do I get the y? I have to plug in x in this equation up here. I can plug it in here like y equal to times negative 1/5 plus 3, like that. So this is giving me negative 2/5 plus 3, which will make it 5 times 1 is 5, negative 2 plus 15, which is 13 over 5. So that's my y value. So I can tell my x is negative 1/5 and my y is 13 over 5. And this is the point they are talking about where the distance is going to be minimum. If you guys have any questions, please let me know in the comment below. If you like the video, then please hit like.